We will now deal with problems concerning constant acceleration motion along a straight line. Take for example, you have a straight line here on which a particle is moving. Now it can possibly move towards the right or to the left, that is forward direction or backward direction. Now, we will not have any problem with the vector treatment because there's no direction change involved. Only thing is plus direction if it is forward, minus direction if it is backward. We can actually define it like this. That is, we just now define our sign convention as in this direction, let's call it as forward direction, we'll call it as plus. That then automatically any quantity which is negatively directed is reverse direction, is we'll have to put a minus sign for that. That's all is the conditions required for this treatment of problems under sign convention. Then the second aspect. Okay, now we'll come to that. Now, first subtopic on this is equations of motion. You may be already aware of the three equations of motion which are regularly being used. That we are talking about now constant acceleration condition. Before we start the equations, you know the symbols which are used for the variables. What are the variables is, now let us say, now this is point A on this line, point B on this line. Let us say now the particle is moving towards right, therefore that is a plus direction, and when it crosses point A, let its velocity be called u, and then when it passes through point B, the velocity be v. Why? Because it will be different from u, because we have said that the velocity is constantly increasing at the rate of acceleration a. What is the what is the definition of acceleration? We know is what is the change, what is the increase in the velocity per unit time, that is per second. Therefore, A we know is what is the change, what is the increase in the velocity per unit time. Now this what, therefore then what happens? The u becomes v after it is traversing this distance a to b. Now let it take a time t to travel from a to b, and also let the distance AB be called as S. Now, therefore, these are the symbols like this. There are actually 1, 2, 3, 4, 5 symbols. What are the initial velocity U, final velocity V, acceleration A, and the time interval T, and the displacement is S. Now, since there are 5 variables, and then we know that each equation as what we know already is, this is called as, this is this equation is generally called as first equation of motion. So then this is linking the final velocity equal to initial velocity plus acceleration times t. Now obvious how this particular logic of this development of this equation comes, because we know that a is increase in velocity per second. Therefore t multiplied by t will give you what is the total increase. Now this is going to give you the change in the velocity. Initially already it is a, therefore add it to the change in velocity, you get the final velocity. Now that is the logic of this. Then the second equation of motion which you may be aware is S equal to ut plus half at squared. Now what is the meaning of this? How this is got is very simple like this. Suppose there was no acceleration, and then you draw the velocity versus time graph. If there was no acceleration, then it continued to be only u velocity right through. Therefore, after a time t, what is the displacement covered? Nothing but the distance covered, nothing but velocity into time. Say, for example, up to this particular this thing, then this is time t, this is u, therefore u into t is the area. That means this is S. S is equal to ut would have been the case if there was no acceleration. But now in this case we know that velocity is increasing, it's not constant. So then we have a velocity time graph, and also now the acceleration increase in velocity per unit time remains constant. That means it will be a straight line graph increasing like this linearly. This at t equal to 0 it was called u, and then at any time t, after a time t, this is called as v. Therefore now this is u, this is v. Therefore now what is the displacement during this time is not definitely ut, this is more than this, and then of course now less than the final velocity into time t. What exactly is displacement? Nothing but the average, nothing but the area under this straight line graph. Therefore, then what the area is? Now the rectangular part, which can be called as S1 equal to U into T rectangle. And then what is this now triangular part, which is equal to S2, let us call it as half, because half into base into altitude. Altitude is what? V minus U. Altitude is V minus U. Therefore, now add up these two, you will get S2 plus S1 equal to total displacement is UT plus half VT minus half UT. Now, to substitute from the first equation V equal to U plus AT, you will get this total displacement equation as UT plus half AT squared. That's how we got this second equation. Then third equation of motion, which you are aware, is V squared equal to U squared plus 2AS. Or you can remember it as V squared minus U squared equal to 2AS. Now, how we got it also is nothing but eliminating time t from the first equation. First equation contains t, second equation contains t. Therefore, now substitute from the first equation t equal to v minus u by a. Put it in the second equation and then unsimplify it, you will get this. This is now the third equation. Therefore, now these are the three equations which are very popular, which we know of. Now, I'm going to now explain like this now. As there are totally 5 different variables, u, v, t, a and s, and then you would find that each of these equations are relating 4 of these variables. First equation is relating v, u, a and t. Second equation relating set of 4 different variables u, t, a and s. Then the third equation is covering u, v, a and s. Now, and therefore there can be 2 more possibilities, because if there are 5 items and then you select 4 out of them each time, then how many such kind of a combination is possible is called as 5C1 in mathematics, with nothing but 5. Therefore, 5 equations are possible. We have already seen 3 equations are very popular. What are the other 2 equations left out? Now the fourth equation, what is the combination which is now left out is, I put it as V, A, T and S. So then we can form an equation like this by using first equation and the second equation, and then we can eliminate u. That is, from first equation substitute u in second equation, therefore eliminating u and then including v, we will get this equation vt minus half at squared. Now compare this form with the second equation, s equal to ut plus half at squared, s equal to vt minus half at squared is another equation which is possible. Let's call it as fourth equation, even though all the books and coaching manuals and the teachers will actually now teach you only the first 3 equations. Let us now try to understand the fourth equation is possible, which is s equal to vt minus half at squared. Now, how it will be useful is, if you are given the data. Now, by the way, before we actually get into this, how to use the fourth equation, we will have to now revisit and then understand how to use the first 3 equations itself like this. Now, as I said, since there are 4 variables in any equation, if you are given data on 3 of those variables, then the fourth can be found out. Then you are now left with the fifth one, which is unknown. How to find it out is, now having got 4 values, now fifth value can be got by choosing any other equation which is giving the fifth variable, linking the fifth variable, and then calculating the fifth equation. Therefore, you know that what all you require in order to know completely define the whole motion is values for 3 unknowns. Then fourth and fifth can be found out. This is for a given situation. I repeat, now we are now dealing with constant acceleration motion conditions only. If it is variable acceleration, then we have to do only calculus method, that we will see slightly later. Okay. Now coming back to the subject, Therefore, now how to use this particular fourth equation is when you are given any of the three values or the four values. What are the four values possible? S, V, T and A. Out of which if you are given any three values, then the fourth value V can be found. For example, if you are now told that you are if you are now told that an object is moving along the straight line from A to B in this direction, then it is passing from A to B in a time of t, and then the distance between A and B is s, and then the velocity at B happen to be v. Then ask the question, what is the velocity at A given that acceleration is a. That means you are given v, you are given t, you are given s, you are asked about u. Therefore we can use this equation. Understand? What have you got now? S is equal to Vt minus half At squared. Now, out of which A you can find out first, because V is given, T is given, S is given. Then using this you can find A, and then putting it into other equation that you got is now you know V you know equal to U unknown plus A is now known, then T is now known. Therefore, now you can use this equation to get the U what we wanted. Okay, so then that is what is the thing. Now, fifth equation which is left out is a combination of U, V, A and T. I'm sorry, U, V, S and T. Now, this combination of what is left out of this, therefore now we can combine them like this. S equal to U plus V by 2 into T. Now this is the fifth equation. How we got it also is by means of combining the first and second equation, second equation, and then eliminating A from here. What is this? A is equal to V minus U by T. V minus U by T. Then substituting it here in the second equation for A, you will get this particular equation. Now, as I said, now derivation is not important, is not required for your NEET examination or JEE examination. However, if you want, you can actually derive it, you can prove it like this by means of, as I said, about finding out the acceleration value from first equation, substituting it in the second equation, and therefore eliminating A from these two equations, you will get this equation. Now how this can be used? This can be used in a kind of situation where any three values are given, U, V, T, and then asked S. Now this equation, I would say, now before that, the fourth equation as such, that is S equal to Vt by half At squared, is not at all very useful, because wherever you can use it, you can use other equations to get to know. Only thing is what happens, you may have to use the other equations twice. That is, two equations you may have to use in order to get this. Whereas this usually what happens is when you get a problem, the problem will actually specify usually one initial velocity but not the final velocity. Therefore, this particular equation will be rarely usable. However, when you want it, you can always use it if you want it. Now, that's the reason why this is not being generally taught. This particular is not generally taught because it is rarely it is used. Whereas, now fifth equation would be very, very powerful equation. You can use it very often. It will be often very useful and a very powerful equation. Therefore, this I would advocate is very useful for you to remember this. Add to your already known three equations as a fifth equation, and then this can be used very well. Now there is a certain amount of a concept logic in this fifth equation. Now let us just recall what is meant by average velocity. Average velocity is total displacement by total time. Now total displacement by total time is V average. This is nothing but, therefore this can be written S is equal to V average times T. Now, what is V average? In a situation where the constant acceleration velocity is increasing from U value to V value by a straight line. The average is now half of this. That means at time t by 2, what is the velocity is called the average velocity. Or because it is now a straight line between U and V, average is between U and V, that is U plus V by 2 into T. Therefore, this V average can be written As I said, I'll just repeat now, I'll caution that applicable only for constant acceleration situations, because only for constant acceleration situation, velocity increases as a straight line increasing. Therefore, this behavior can be written as average between the initial and the final velocities. Therefore, this into t will be s. That is the logic of this particular very powerful equation. Now, we are now discuss. I have now explained to you about what are the equations, and then how it is to be used is, if you are given any three values unknown, the fourth and fifth can be found out by means of choosing the appropriate equation. Then let's now try. And there is one more point which I want to tell you is, in general, we are now going to practice with sums which are other than the gravity, motion under gravity, because motion under gravity actually is nothing but vertical motion when you are dropping object from a height, or when you are throwing upwards, vertically upwards, a stone. Now such kind of cases, now acceleration is already known as g. In fact, now what we normally do is, for like free fall under gravity situation, upward direction is taken usually as positive, and then because acceleration due to gravity is acting downward, and it's called g. That is, acceleration equal to minus g. You put it because it is downward acceleration. This is a usual sign convention which we use for this situation. Therefore, let us take up these examples about a vertical motion under gravity after practicing a few sums based on the horizontal line motion, like this. Why? Because now these three equations of motion can be converted, because we can put a equal to minus g, and then have a set of ready formulae for application for vertical situations. Something like for example, suppose now you want to know in the vertical situation, suppose you are throwing vertically upward with the initial velocity u. Upward is positive, therefore I'm just calling it as now u only. Then it is going up to the top and then coming back, like vertically falling down like this. Therefore, then what is the maximum height reached? Now, if it is like this, then what happens is, now this is u, whereas at the topmost point we know that v need not be given because it is have to be equal to 0. Then what is the displacement is called h. Displacement is vertical, therefore it is yes. Therefore, know that there are three data is there, that is u equal to u, v equal to 0, we'll have to put it, and then s equal to h if it is given. Then what is the time taken to travel upwards? Now t is unknown. Then what other thing is known? Now a is minus g is known. Therefore, there are actually four equations. In fact, therefore, then s need not be given. S is a question mark. That is, we are asked to find what is the maximum height reached. That means u is known, and then v is now known 0, and then a is known. Therefore, you can find h, you can find t. Like for example, now in this case, what we do? First of all, let us now form the equation involving s. Therefore, s is equal to h. I am putting it as because h is positive, direct upward, because displacement is from bottom to top. h equal to what we are going to do is v squared minus u squared by 2a. That formula we are going to use. Therefore, now the formula itself can be converted as v squared equal to u squared plus 2 into a is minus g into s. Okay, this situation where you are throwing upward from here with the initial velocity u. Now, then what happens is, this can be used as v squared minus u squared by 2g equal to s. Correct? No? V squared minus u squared by 2g equal to s. Minus s, or rather, this can be converted as u squared minus v squared by 2g is the s. Therefore, now this is nothing but s is equal to h is given by u squared is a given data minus v is 0 divided by 2g. Or rather, you can have a ready formula that h equal to u squared by 2g for the maximum height reachable. Therefore, such kind of a ready reckoner formulas can be easily got. Very similarly, let us take for example, what is now the time taken to reach the topmost point. Suppose the question is about the time taken to reach the topmost point. Then you can use u v equal to 0, a equal to minus g, and then time t, and then use the first equation v equal to u plus a t. Therefore, this is a general formula again can be taken as v equal to u minus gt will be under the case of a gravity situation. Where now it is positive is u is thrown up, and then v of course is any time after time t. Now for this case we are asked to find what is time t equal to time t u minus v by g, which is nothing but now u minus 0 by g, or rather now the ready reckoner formula is time taken to reach the topmost point is u by g. Therefore now such kind of a ready formula, that this is 1 h equal to u squared by 2g, and then the time of flight, that is time of going up, that is called time of ascent, is going to be u by g. Now such kind of ready reckoner formula can develop for the pre-fall situation under the gravity. That's the reason why I am saying that let's first now do the practice the sums under the horizontal motion with constant acceleration, then take up the gravity motion under the vertical direction. Right. Now, as I said, let's now practice some of the examples of questions which were asked in the past NEET examinations, NEET PYQs. Take the first question, question number 4, NEET 2023. Just read the question, try to understand. I'll explain to you what is the step-by-step method of doing such kind of a sums. Now, once you get used to it, once you master the how to do the sums by means of step-by-step formal method, then you can shortcut whatever way you want, and then you can actually do the sums later yourself. But initially, now try to do it by means of a step-by-step approach. Use the formula. I'll explain to you what are the variables given, and then we will try to learn the step-by-step way of solving the problem. Okay, let's read the question. A bullet from a gun is fired on a rectangular wooden block with velocity u. This is a situation. Let me draw. Now this is the rectangular block of wood. A bullet is fired. Therefore, it's got an initial velocity u is given. Then the bullet travels 24 centimeters through the block along the length horizontally. That means now this is, let us say now it's now traveling a distance of s equal to 24 centimeter up to this point P, up to the point P, then horizontally. Then velocity of bullet becomes u by 3. That means at this particular point, the final velocity v becomes equal to u by 3. U is a given data, v is a given data, u by 3. Then s is a given data, 24 centimeters. Therefore, now you already got 3 variables. Therefore, it will now satisfy. You can find the 4th and 5th variable, whatever is being asked. Okay, that much is known. Then it further penetrates into the block in the same direction before coming to rest exactly at the other end of the block. Therefore, now from this particular P, it reaches the end of the block. Let us call it as Q, and then comes to rest. Here. Therefore, now here what happens is we will now do either what we can do is now this travel P is now a separate second data. This is P, this is Q, and the distance is unknown. Distance is not given, and then this got initial velocity for that. This P is naturally is u by 3, that is already given, and then it says now at the end of the block it comes to rest. It says end of the block it is coming to rest exactly at the other end of the block. Therefore, here what happens, v equal to 0 is a given data. Now, what is missing from the data is acceleration is not given. But we have to assume that the resistance of the wood is going to give a constant acceleration motion only. acceleration is not given. Therefore, now we'll take the first situation and then the second situation is here. Therefore, we'll form now two equations. What is now given for the first situation? I will now explain to you step by step, detail. Therefore, don't consider it as a kind of a waste of time, because initially you have to actually practice doing it in a kind of methodical manner so that you can master the technique, and later on you can actually do your shorten your method of working. Now, therefore, for the first data, what is given is u is given as u, v is given as u by 3, a is not given, s is given as 24 centimeter. For the present, I am not converting the 24 centimeter into meter because all the options I am finding is given in centimeter only. Therefore, no need to convert it at this stage. Okay. Then the time of travel is not given. A is also not given. Okay. Now the second situation is u is given as u by 3. V is given as 0. A is again not given. S is not given, but then it's got to be found out, because why they are asking is what is the total length of the block. That means we have to find this second situation, yes, add it to the 24 centimeter to give the answer. S is not given. Of course, now T is also not given. Therefore, this now that two sets of data which are given. Let's now try to put then which are the variables which are here? U, V, A, and S. U, V, and S are given. Okay. Therefore, now we are going to find that. You can find the T or you can find the A. Whereas now A is important because now we're going to the same A. Therefore, let me call it as now A is called as A but not given, and then A is now the same A which is not given. Therefore, now A is a common variable between these two situations. Therefore, let's now use a fourth unknown variable as A from the first and second equation. Therefore, let's now form. We are going to use, therefore, v squared equal to u squared plus 2as from this situation. Therefore, now in this case, what happens? U squared by 9 equal to u squared plus 2a unknown into 24. You just keep it as 1 centimeter. This is the first equation. Then the second equation for second data is now 0 squared equal to u squared by 9 plus 2a. Same a into s is unknown. Therefore, from here we have to find the s. Therefore, now what we will do is we will just now, this is the first equation and the second equation. We have to now solve for s unknown here between this. So how do we do it? Is from first equation, I'll now write it as minus 8u squared by 9 equal to 2a into 24, first equation. Then the second equation is minus u squared by 9 equal to 2a into unknown s is the second equation. Now divide it between these two. Then you have right hand side you have 24 by s. Left hand side you have 8. Therefore, s equal to 3. S equal to 3 is for the second distance. Therefore, already now you got the 24 centimeter. Therefore, total width of the D. This is D is the length of the block is nothing but 24 plus 3 equal to 27 centimeter. Understood? Therefore, answer is option 4, 24 centimeter. Now, let's now try and practice the next situation. A car is moving with a speed of 40 km per hour can be stopped by applying a brake at least after 2 meters. That is, the car is moving in this direction. Suppose now this initial point, it has got a u equal to 40. I am just keeping it only kilometer per hour itself. Now, right at this stage, later if required, we can convert it into meter per second. You know the conversion already between kilometer per hour, meter per second. Why? Because now this kilometer per hour multiplied by 5 by 18 will give you meter per second, that you know. In this case, for example, now 40 into 5 by 18 will be the meter per second in this case. As I said, we will not worry about it right now. We will convert it if required finally. I don't think it may be required. Let's just wait and see. Therefore, now the first data situation is given like this. The car initial speed is 40 kilometer per hour, can be stopped at least after 2 meter mean, that is a maximum braking retardation if you apply. Then it can be stopped at 2 meter distance. That means this is V equal to 0 with acceleration is A max. Acceleration means retardation. That is minus A max. Retardation minus. Right. Then this distance is 2 meters is given. Then the second situation is what they are given. Now the same car is moving with a speed of 80 kilometer per hour. Suppose now it is now the second situation is this first situation, first data. Second is suppose now u equal to 80. Then the same maximum retardation, A max, V can be equal to 0. They are asking what should be the distance. Let's call it as S. S is unknown, which yes we have to find out. This is the second situation. Therefore, for the first situation, calculate the situation. What is the formula to be used? Now, U is a given data, V is a given data because 0, and then A is unknown, but then it is going to be common for both situations. Therefore, use that as a kind of a common variable. Therefore, A is not known, and then S is given data 2. Therefore, there are now 3 variables are given. And then again, what is the equation which is common for this? Using these 4 variables, V squared equal to U squared plus 2AS is the equation to be applied. In this case, what happens is, this is 0 squared equal to 40 squared plus 2 into A unknown, let's call it A max is A, which of course is negative A, and then S is 2 meters. This is the first equation. What about now for the second equation? You got U is equal to 80. Therefore, V is again going to be 0. 0 equal to 80 square plus 2A into unknown S. Therefore, from here, obviously, now if you just find it out, it will be 4 times. The answer will be 8 if you use from this. Therefore, 8 meter is the second sum answer. Then we go to the next sum, which is a car is moving along a straight road with a uniform acceleration. It is passing, it passes through 2 points P and Q. This is point P, this is point Q. Car is moving between this and this in this direction, separated by some distance. We do not know what is the distance. Okay, let it be. Then this with a velocity of 30 km per hour and 40 respectively. That is when it is passing. This is U is equal to 30. I am also keeping the same as kilometer per hour because I am saying that the options also is maintained in the same units. This is 30 and this is 40 is given. And then the question asks, what is the velocity of the car midway between P and Q? Midway between P and Q is this particular point. Let us call it as R point. Suppose this is now called as S. Then this distance is S by 2 and S by 2. Now, what is the velocity here? Midway. Okay, unknown, V is unknown. We have to find it out. V. Okay. Now, this like this. Therefore, then we'll just use the equation. What are the equations which are used is U, V, S, and of course A has to be common because they are saying it is with a uniform acceleration. Therefore, A is common. Therefore, A is here, A also is same here. Therefore, again it is nothing but the same equation, V squared equal to U squared plus 2AS. Therefore, now let us put this unknown. Now we are taking the first part is up to the half distance. Second part is another half distance. Therefore, then what we are going to do is, we are going to say now V squared unknown equal to, that is at velocity at the point R is V equal to 30 squared plus 2A into distance equal to S by 2. Then the second part, what the equation is, now here that's what I said earlier is, now second part, what is the initial velocity is V. Therefore, V square, what is final velocity equal to 40 squared plus 2A into S by 2 again, because same distance again. From these two equations, what we can do, we can now subtract the equation. Therefore, we find that v squared minus 40 squared equal to 30 squared minus v squared. That means 2v squared equal to 40 squared plus 30 squared, which is equal to 50 squared. Therefore, v equal to 50 by root 2 can be called as 25 root 2 kilometer per hour is the speed. 25 root 2, where is it? See, understood? Fine. Now let's take the another question. Particle moves on a straight line with a constant acceleration. Moves along a straight line with a constant acceleration. It changes velocity from 10 to 20 while passing through a distance of 135. This is 10 speed, this is 20 speed, distance is 135. What is the value of t? Now this is u is given, v is given, s is given, t is to ask for. Now recall which equation combines this four straight away. S equal to u plus v by 2 into t. 135 meters is equal to 10 plus 20 by 2 into t. Therefore 15, 135. Answer must be equal to 9 seconds. Okay, no? Now let's take one more equation. Then by the way, now there is one more equation which is being taught to you people, which is called as a distance covered in the nth second. Do you remember? That equation is called Sn equal to u plus a by 2 into 2n minus 1. This is called the distance covered in nth second of travel. Now, this actually is not part of the equation number what we talked about 1, 2, 3 plus additional 4 and 5, because this equation is a kind of special cases equation combining. Now supposing now starting from here u and then this is some distance total s covered in t equal to n seconds, and then t equal to this is up to this is now t equal to, this is called s dash equal, this is for t is equal to n minus 1 second. That means now what is this particular distance? Leftover distance is this minus this is nothing but what is covered in the nth second. Now how do you calculate this? This what you do is you take it as this formula is, this gives you s is going to be given as u into t is n seconds plus half a n squared. Then what about the s dash is given for n minus 1 second? This you're going to give by n minus 1 plus half a into n minus 1 second. Then what is now the difference between them is the nth second what is covered. Subtract it, you get now this minus this is u plus half a into n squared minus n minus 1 whole squared. This is what you are having it as Sn equal to u plus a by 2 into this difference comes in this bracket term comes to 2n minus 1. That's how we got this particular equation. Therefore, nothing but applying the second equation of motion twice in order to find the difference between the two distances covered in the n second as well as n minus 1 second. Now, we will just see. Let's now try this problem. A small block slides down on a smooth inclined plane starting from rest at time t equal to 0. We don't have to worry about inclined plane or not, because anyway now whatever be the straight line on which the particle is traveling, it is understood it will have a uniform acceleration, constant acceleration. It doesn't matter about the line of travel and its direction. Let Sn be the distance traveled by the block in the interval from t equal to n minus 1 to t equal to n seconds. Now in this interval between t equal to n minus 1 to t is equal to n second mean it is Sn in our terminology. And then the ratio Sn divided by Sn plus 1 means between t equal to n to t equal to n plus 1 second. That particular 1 second interval is called Sn plus 1. Therefore, they are asking what is the ratio between these two. Now it is pretty simple to answer because what is the numerator in this particular ratio is Sn is u. Now u is given as now starting from rest. Therefore, u equal to 0. U is equal to 0 already given. Therefore, Sn formula becomes half a unknown of course, but then it will be same for both numerator as well as denominator. Half a into 2n minus 1 is a Sn formula. What about n plus 1 second? We have to replace n with n plus 1. Therefore, you will get it as 2n plus 1 you will get. Why? Because 2 into n plus 1 minus 1 will be nothing but 2n plus 2 minus 1 equal to 2n plus 1. That's what we are putting as the denominator. Therefore, ratio is 2n minus 1 to 2n plus 1. Option 2. So then very simple. Next, then you go to the next question. Let's try. The distance traveled by the particle starting from rest and moving with an acceleration. Acceleration is given as 4 by 3. In the third second, starting from rest, u is equal to 0. During the third second mean we use that formula Sn and put n equal to 3. Therefore, Sn formula says u plus a by 2 into 2n minus 1. You simply substitute u equal to 0 plus a equal to 4 by 3 into 2n, 2 into 3, 6 minus 1 equal to 20 by 3 is the distance covered in meters. Correct? No? A by 2. Therefore, this is 20 by 3 into 2. Therefore, 20 by 6 or 10 by 3. 10 by 3 meter is the answer. Okay. Now this is a practice what we have done. Now let's take the motion under gravity situation kind of problems. Let's read this particular question which asked in NEET 2023. A horizontal bridge is built across a river. A student standing on the bridge throws a small ball vertically upward with a velocity 4 meters per second. The ball strikes the water surface after 4 seconds. The height of the bridge above the water surface is. Now it's like this. Now there is a water below. This now the bridge height. Let's call it a h. This is what we are supposed to find out this. Now this from the top of the bridge. A boy is throwing a stone vertically upwards with the initial velocity u is given as 4 meters per second. Therefore, I'm just not writing the units now because all are SI unit. I'll just leave the units writing. This is 4, and therefore what happens is this goes up and then reaches 0 velocity and then comes back and then hits the water below. Now the total time of travel is given as 4 seconds. Total time is 4 seconds. Then they are asking what is height of the bridge. Now it's like this. Now we will now have to be careful because such kind of situation you'll always find that you have to use the plus minus signs very carefully. And then usually we always take that upward is taken as positive. Not necessary to follow the convention every time. It actually suits you, whichever convenient you follow. But generally what I'm saying is whenever you are having now mix of the two directions. Suppose the question is only about now vertical motion upward only. Then you take because there's no change of direction. Therefore only upward alone is coming. Then don't worry about plus minus because everything will be only plus. And then similarly now you are now considering, let us say now a stone is dropped from some particular height, etc. Therefore there is no question of the change of direction because everything is going to be only downward motion only. Therefore when there is no change of direction, even if it is a vertical motion, even under gravity, suppose you are considering only one way direction, then you don't have to bother about now using plus minus signs. You can use only plus. Whereas whatever problem involves change in the direction during the particular problem, then you have to be careful. Then you use a convention. Now nobody prevents, you can use downward as positive also if it is okay with you. But then generally I am saying all of us are used to taking upward as positive. Therefore stick to it. Therefore there is no need for any confusion between two people going through the solution. Therefore now on that particular premise, we are now taking upward as positive mean, then u value is taken as positive. Okay, I don't have to write plus 4, but then just for the sake of clarity, I am now using plus 4 for this. Then what about the acceleration? Acceleration is now downward, therefore I'm going to put it as minus g, which I'm going to call it as minus 10, because we have been asked to assume that g equal to 10 value. Therefore, a equal to minus 10 meter per second squared. I'm just leaving it because it's all SI unit. Then what is given in now the total time. Time, there is no question of a plus minus because always only a plus. We are not talking about negative times at all. Therefore, is equal to 4. And then what is asked for is displacement. Displacement is, I'm going to call it as minus hy, because what is the initial point top? What is the final point ground below? Therefore, what is the direction of the so-called vector direction? Downward. Therefore, I'm going to call it as downward is negative, no? Therefore, I'm going to put it as h. Therefore, now, what are the variables u, a, t, and s? They are obvious. Then we have to use a second equation, s equal to ut plus half at squared. Therefore, I am going to say that minus h equal to 4 into 4 ut plus half into minus 10 into t squared is 16. Therefore, it equals 16 minus 80 equal to minus 64. Minus h equal to minus 64, h equal to 64. Option 2. Understood? Now, this is what it is. Now, do you need to can you actually now use this, do this sum totally mentally without having to use a pen and paper? Less likely, because now this thing is involving, equation is involving ut plus half et squared, means now square term also is involved. Therefore you have to do, there are actually two terms to be added up. Therefore it is difficult to do everything only mentally. You can actually try, but then there are likely to be mistakes also happening if you try to avoid writing it down with pen and paper and then using only mental calculation. Whereas now the same problem becomes quite easy to do it mentally if instead of this single equation s equal to ut plus half at squared, you now try to use two equations and arrive at the same answer. Okay, let me now tell you how. No. I'm now going to now explain to you about how to use this so-called fifth equation, which is what I taught you as s equal to average velocity kind of basis. That is u plus v by 2 into t, what I told you, no? Now, can I use it? Now in this case, now s is equal to minus h, I know that. Therefore, I have to find it out. Whereas u I know is 4. Whereas what is the final velocity when it reaches the water, I don't know it. Whereas now I can actually not do it mentally. How it is? Now the total time taken is 4 seconds. Therefore, within 4 seconds, there will be a change of velocity. How much? Because g is going to be retardation minus. Therefore, now it is going to give you what is now the delta v during the particular 4 seconds. So the minus 40 is going to change in velocity, because each second is going to give a minus 10. That's a reduction by 10 units. Therefore, now it's going to give a minus 10 change in the velocity for each second. 4 seconds, therefore minus 40. Now it's not possible for you to actually do the calculation mentally. Yes, very much, because the numbers are also are very simple numbers only. There are no kind of a big decimals or fractions involved in the numbers. Therefore, now it is known that g equal to 10 is obvious. Therefore, reduction in the velocity is going to be every second 10 units. Therefore, 4 seconds total time is going to be reduction in 40. Therefore, now it is going to, what is now the initial velocity 10? What is initial velocity is 4. Initial velocity 4 is going to be reduced by 40, which means final velocity is going to be minus 36. Therefore, then this I can do it mentally. Therefore, now v equal to minus 36. Minus actually means downward direction when it reaches the water surface at the bottom. Therefore, then what is average between u and v now in this case? Average between plus 4 and minus 36 is going to be 16. Why? Because plus 4 minus 36 is going to be minus 32 divided by 2 for taking the average. Therefore, minus 16 is going to be average, minus 16. Then what the formula says? Average velocity into time. Time again, as you know, is 4. Therefore, minus 16 into 4 is minus 32. Minus 16 into 4 is, just one second. Let us just do it. Now, u plus 32 into t equal to, what is that? One second. The minus 32 minus 16 into 4. Well, because t equal to 4. Therefore, minus 16 into 4 is minus 64, minus 64. Minus 64 is a displacement which is nothing but the height h downward. Now, tell me something. Now is mental calculation, will it be faster or the physical calculation will be faster? Now, in this case, because now it is actually pretty simple numbers only, maybe now both will take the same time, but then it's much more convenient to do it mentally fast, because there is a possibility that you can do it really fast. And also, there is a possibility if you now do this because of quadratic numbers involved, like the t square term, etc., as well as adding, then it is quite likely to go wrong, therefore committing mistakes. That can be avoided if you can do it mentally like this. Okay, I'll just repeat now the mental process of how I'm going to do it. 4 seconds, each second minus 10, therefore minus 40 is the delta V. Initially it was plus 4, therefore final value will be minus 36. Therefore then what is the average between 4 and minus 36? Minus 32 by 2 is equal to minus 16. Therefore then what is minus 16 into 4 equal to minus 64, answer. Now this is the way I would actually proceed like this. Okay, therefore now that's why I said now the fifth equation, which is something like u plus v by 2 into t, which is based on something like the average velocity concept, s by 2 equal to u plus v by 2, and then this average velocity kind of thinking holds good only if it is a uniform acceleration kind of problem situation. Therefore, in such a case, problem could be attempted totally mentally, and then possibly can be done much faster than the pen and paper method. But then it involves now 2 stages. What are the 2 stages here? What is this? Pen and paper uses only one equation straight away, one step only. S equal to ut plus half at square situation. Of course, involving the calculation of the square term and then adding, etc., etc. That's why we are saying requires pen and paper. Whereas now in the case of mental calculation, it involves now 2 equations mentally. What are the equations? Of course, now the mental equations are actually pretty simple. You don't even think about using the equations in this case. You only think about the logic of it. What is the logic which you are applying? Acceleration is change of velocity per second. Therefore, now in this case, what you are doing is 10 reduction in the velocity every second, 4 seconds, therefore 40 reduction total from initial plus 4, therefore minus 36 finally. Therefore, this you are mentally computing. Actually speaking, you are using the first equation v equal to u plus EAT, but then you are not thinking about using the equation, you are calling it as a mental calculation from the logic part of the acceleration definition. Therefore, that is the one equation which you are using. What is the second equation then? Then you are using putting this particular v value in the average velocity equation, s by t equal to u plus v by 2. There you are computing it again mentally. U equal to 4 upward, therefore v equal to minus 36, the average is minus 32 by 2, minus 16 into original time, total time 4 equal to minus 64. This is now mentally you are computing it based on average velocity concept, which in effect is nothing but using the fifth equation only, practically speaking. Therefore, this is what you are doing. Therefore, now this method is much more convenient, I would say, especially if the numbers are pretty simple, there is no kind of a decimals which are involved in it. Even in the case of decimals involved in it, I would rather feel that this method of 2 equations doing mentally is much faster and also much more error free as compared to decimals involving, especially now the time square, decimals calculation will be much more cumbersome and then will take more time and then possibly even more error prone. Therefore, with this advice, I want to now consider this particular fifth equation as as much more usable and much more powerful than all the other equations. Okay, let's now take the next example on the gravity. Your ball is thrown vertically downward with a velocity of 20 meters per second from the top of a tower. There is a tower. From the top, it is downward 20 is u. 20. Again, as I told you, because SI unit, I am just writing down the SI unit every time. U equal 20 downwards. Then hits the ground after some time with a velocity of 80. 80. Okay, V equal to 80. What is the height of the tower? Okay, 80. And therefore, what you are going to height of the tower is 80 squared minus 20 squared by 2 into G, 10. Okay, this is going to be the height of the tower. Now, this can be done. What is this coming to now? This is now the numerator is u plus v into u minus v, 60 by 20 must be equal to 3000. No, not 300. 300. Okay, now. Here also, I would rather use this kind of a method. Now, two-step method, because I am going to now use, I'm going to use fifth equation, u plus v by 2 average into t, for which now I'll have to first compute the t, because 20 increases to 80, therefore now 6 seconds. Therefore straight away now I would know that because g is equal to 10, 20 increases to 80, therefore it should be only 6 seconds with the travel. Therefore now I am going to say now 20 plus 80 is 100 by 2, 50 into 3 into 6 equal to 300. Therefore now this also I can do it mentally much faster, because pen and paper involves now squaring. Okay, understand? Therefore now frankly speaking, I would rather feel that such kind of height calculation becomes mental much more faster than any other kind of method. Now, by the way, now there's just one more way of thinking I want you to understand. Now, you now take this particular equation, S equal to ut plus half at whole squared. I mean, S equal to ut plus half, I'm sorry. S equal to ut plus half at squared. Now this can be written as, now you can write now u plus half at and then take the t out common. This is nothing but, let me now write it as, this is nothing but, now take LCM 2u plus at by 2 into t. This is S. This can be written as u plus at by 2. Okay, 2u plus, no, or rather let me write it as, this is equal to u plus at by 2 into t. Now this is nothing but S equal to u plus, what is u plus at is v by 2 into t. Correct? No? Now I'm going to say now, in some cases, maybe even faster to now do by this particular formula. What I'm saying is, now you take one t out as common. If u plus half at. Now take this particular situation here. Now instead of you actually calculating it, what I wanted you to do was to try and use this particular formula, S equal to this formula. Now no need to do the particular formula, because you can use this formula itself. Okay, yes. Now, what is now the time taken, that you can find out, because 20 has gone to 80, therefore 6. Therefore, then what is half A? Half A in the case of, especially in the case of a G situation, gravity situation, this becomes much faster, because half A can always be remembered as 5. That is, G equal to 10 can be remembered as G by 2 equal to 5 always. Therefore, you can remember it as, now half A is always 5. Therefore, 5t. Now I am going to say that try and use this particular equation mentally. U plus half at into t. How do it is? I'll first calculate this part of it. That is this part as mentally first. That is 5 into t. Now in this case already now I mentally calculated t equal to 6, because 80, my 20 has gone to 80, therefore it should be 6 seconds. Therefore t is 6 seconds. Therefore half a is equal to 5t is equal to 30. Therefore this part is now 30. And then u is now 20. Therefore 30 plus 20 is 50. Let me just now do it once again. Half a. What is now a? T equal to 6. What is half a? 5. 6 into 5, 30. 30 plus 20 is 50. Therefore now 50 into 6 is 300. Straight away I am able to say this particular method. Therefore, I would even suggest that that is in which case, only if you are trying to do the s equal to ut per half a t squared as a whole, then you have to do the quadratic multiplication t squared finding, and therefore you require pen and paper. But if you are splitting it, if you are taking the t out as common and then using as a kind of two factors, then definitely you don't have to do a pen and paper method. You can simply think of it mentally also, as I said, because 5 into t 6, 30 plus initial u 50 into t again 6 equal to 300 can be accomplished mentally much faster. Therefore, this method is even much faster than using this particular s equal to u plus v by 2 into t. You can think about it. There are ways. Now, I am now giving you such a kind of a detailed small tips, even though it's all very low level kind of calculation tips. I'm still giving it because I find that many of the NEET appearing people are little bit jittery about doing this even arithmetical calculations. Even though they might have taken mathematics as a kind of subject, I find that many of these NEET students are finding it difficult to cope up with the kind of ordinary mathematics to the extent they don't do mistakes finally, they just do calculation. Only thing is they take a very long time trying to finish even the small calculation, which means they are not handicapped because they have to cover 45 questions in let us say within 1 hour. Therefore, now they find it difficult to complete. Therefore, even though they know all the concepts well, they find they're taking more time for calculation, ordinary calculation. Therefore, they're suffering from lack of time to complete the whole paper. That's the reason why I'm giving you all kinds of small tips, mainly aimed for NEET level people. Therefore, I want you to now think about it. Try to practice various ways of doing things faster. And as I said, now mental definitely may be faster if we can accomplish it by means of, and also you become error free because there are now terms like quadratic etc. You are eliminating in your mental calculation by means of a simpler equations. Okay, now this is what we have said. Now we take the next question again. A boy is standing at the top of a 20-meter tower height and then drops a stone, assuming g equal to 10 meter per second squared, the velocity with which it hits the ground. Now they are giving, now let us say now, this is now dropping. Therefore u equal to 0, this is now dropping, u equal to 0. Now that only one-way travel is involved here, you don't have to worry about putting minus for every one of the variables. You can happily assume everything as plus. Therefore, no need to put the sign now because only one-way direction involved. Now u equal to 0 because it is now dropping, free dropping. Okay, free fall from a height. H is equal to 20 meters. Now g of course naturally equal to 10 always. The velocity with which. Therefore, now what have we got now? V is asked. Therefore, v square minus u square 2as. Therefore, then what happened? V squared equal to 2 into g into s20. Therefore, this must be equal to, v must be equal to 20 meters per second, obvious. Okay, now this what I meant initially is I said that there are some easy formulas, direct redirectional formulas for this vertical under-gravity situation kind of problems. Like there are only things like this. Now, if you throw from ground at a velocity u, it will reach a maximum height how much? H max, H equal to u squared by 2g. Okay, this is one formula which is important. Therefore, u squared equal to u squared by 2g. 2g is the maximum height reached if it is thrown from. This is one equation which you have to remember. That is h is equal to u squared by 2g. Now automatically this now gives you another kind of situation. when you're dropping from a height, drop means u equal to 0 and the height is h, then it reaches with a v equal to root of 2gh. Okay, this is another formula which is quite useful, formula number 2. Now you can see that this is nothing but this, now the reverse of this, because h is equal to u squared by 2g means u squared is equal to 2gh. Now this is nothing but v squared is equal to 2gh. Okay, now that is now this problem is the reverse of the problem. What is this now? Second problem is the reverse process of the first problem. Throw upward with the initial velocity u takes you to the maximum height h. Here in this first situation is you are throwing upward with the velocity 2gh square root of will now take you to maximum height h. Now this is now maximum height means v equal to 0 finally. Whereas now this is now ulta process, that is you are taking u equal to 0, that is you are actually dropping it now. Is now that's coming back to achieve the same velocity with which it was thrown upward. This is the same velocity as reaching downward from the same height. Therefore, this is nothing but the reverse. That is the when you throw upwards, it reaches the maximum height, and then this is now the reverse process. This is now your question number 1. This is question number 2 here. Nothing but the same. Therefore, that's why you are getting the v square equal to 2gh. Here u square equal to 2gh. Understand that. Therefore, now these are the two equations which I want you to remember this. Okay, or rather you can simply remember as one equation 2gh. 2gh is a formula for velocity square, especially one end velocity is equal to 0. Okay, that is one end you are having velocity equal to 0, other end it is root of 2gh, gets you to the maximum height of h. Okay. If you can remember this, then that becomes very simple, even equivalent to only one formula remembering. Then the second thing which I want you to remember is, of course, is now that is the third one I would say is now the time taken. Suppose you are now throwing with u, then the time taken to reach the top v equal to 0, time taken is u by g, because as you know that u becomes every second, it now decreases by g. Therefore, when it becomes 0, it takes a time of u by g second. Therefore, this is the important third formula you have to use. Okay, then the fourth formula you have to remember is now the same situation. You are now throwing and it reaches maximum height of h. Then what is the time taken? T is equal to root of 2h by g. Okay, how we got it as, because here is going to be now 0 v. Therefore, what we are going to say, take it as s is equal to vt minus half gt squared. Remember, this is the fourth formula which I gave you. Now here is going to be 0. That means s is h is equal to always equal to half into g into t squared. Therefore, time taken is nothing but 2h by g square root of. This is what I said about this time taken for rising. Now the ulta or the reverse process is also now when you are dropping from u equal to 0, then the time taken to fall through a height h, t also is now reverse process of this particular fourth equation. The fifth also is nothing but the time taken to fall to reach the ground is given by root of 2h by g. Because the same value, this u equal to 0 makes it to equal to half gt squared is equal to h. Therefore, t becomes this. Therefore, this is now this fourth and fifth are the same equations. T equal to 2h by g root of, and also now the first and second are same equations. U squared or v squared equal to 2gh. This is now the same. This is now the same. Of course, now t equal to u by g is very normal, because you know that every second reducing by g means u becomes 0. in time t equal to u by g. Okay, understanding? Right. Now let us now go to the next question. Ball is thrown vertically upward. It has a speed of 10 meter per second when reached one half of its maximum time. How high does the ball rise? Now, okay. Now we'll take the next problem. From the next problem, I'm going to ask you to now look at the solving the problem in a slightly different manner. In the sense, there is no need to follow step by step because there is a kind of a shortcut way of thinking. Now, like this now, especially when I said when you are dealing with the gravity fall situations, vertical upward downward, you can actually reverse the process and then solve the problem quite easily. That is, instead of going up kind of a motion, you can think about reversing it from coming down from the top, and therefore you can actually solve the problem quite easily in many cases. Let's now try and then practice such kind of situations so that you can understand them better and therefore put it to use when you are actually facing the exam situation. Now take the next question. I'll now explain to you also how to do the reverse thinking. Your ball is thrown vertically upward. It has a speed of 10 meter per second when it has reached one half of its maximum height. How high does the ball rise? Okay, now to take the drawing like this. Ball is thrown from below. Below it goes like this to the maximum height. Let us call it as h. Then it says what the data given is when it reaches h by 2, that is half the height it has reached. At that time, its velocity upward is 10. Now it says what is h. Now pretty simple to now look at it because when it having initial velocity 10, it reaches a height of h by 2 as maximum. So that's the meaning of this particular problem. That is, from this point, it reaches a height of h when velocity becomes 0. So for now you have a simple situation. U equal to 10, v equal to 0, height is equal to h by 2, and of course g is downward equal to 10. Therefore, then how will you actually now solve? You'll use a famous formula. What I told you is u squared by 2g is a h. Now in this case, h by 2 is the height, not h. H by 2 is equal to u squared by 2g is equal to 5. That means h is equal to 10. Understand? Now let's now repeat it like this. Now this is now 10 meter per second is the velocity when it is middle of its way up. Now you can actually now you do it also reverse way also. Look at it. Now going from here to the top is same as coming from here to this particular point. Now this is equal to half g t square. Okay, fine. Or even this half g t square. Now what is now the time taken for from 0 to velocity 10 reverse direction 10 1 second. 1 second. Half g t squared is 5. Therefore this h by 2 is this height is 5 mean total height because I already given it is a midpoint. Total height must be 10. Okay. There are now so many ways of doing it, but the simplest way is look at it from the half value. U squared by 2g will give you the height up to the maximum point. Therefore u squared by 2g gives you 5 is this full distance. From here is 5. Therefore now double it to get the full height what they are asking, 10 meters. Okay, now this now we are not now exactly now applying. You can actually apply like this because u initially is unknown, v is equal to 10. You can also solve it by means of the kind of a longer route of step by step from the given situation. What is the given situation? Initial velocity is unknown u, whereas final velocity here is 10, and the distance is h by 2, and then the time take, and then the g is negative minus 10. Therefore, from here what you can do is you can find the equation is giving h by 2 equal to v squared 10 squared minus unknown u squared divided by 2 into minus g. This is one equation. Okay, here we do not know h, we have to find out the h. We also do not know u squared. This is just one equation. Then the second equation is now the same this thing you can write h equal to h equal to, now use, because 0 squared is the final, minus u squared is same, into 2 into g. Therefore the word is now second equation. Therefore from here and here you can use it, because this actually means divide this and this, or rather now multiply this by 2. Okay, fine. We had to eliminate the u square, right? Therefore now this is becoming minus 2. Therefore divide this, what you are getting it is 10 squared minus u squared by minus u squared equal to 1 by 2. From here you can actually solve it as 200 minus 2u squared equal to minus u squared. Therefore u squared is equal to 200, u squared equal to 200. Now put it into one of these equations. This equation, for example, u squared is equal to 200, you put it there, h is equal to minus 200 divided by minus 20 equal to 10 meters. Now same way as what you have got. Now this kind of a step-by-step approach is quite unnecessary, because you just now look at it from this particular point of view. From the velocity 10 is going to 0, therefore 10 squared by 2g. Okay, 10 squared by 2g gives you 5. Therefore 5 is a half the distance, therefore 10 is very, very fast method of solving. That's what now is being explained by this kind of a case of a example. Now some more examples of shortcut thinkings. Now let's take now the second case. If a ball is thrown vertically upward with a speed of u, the distance covered during the last t seconds. Now in this case it is given like this: from the ground the ball is thrown vertically upwards, so it reaches some particular maximum height. Now the time taken we know is for the full, this thing is for the reaching maximum height is u by g. Now we say now the last t seconds means now this now total time is u by g time, whereas now this is now t, this is now time t. Now they are asking what is the height reached in the last height. Now pretty simple. If you just look at it, now reverse the process. Now at the topmost point velocity is going to be 0. Therefore it's now a free fall. Just reverse the whole step, reverse the whole problem as you look at it from the reverse problem. That means it is now dropped from the height, from a height. Okay, some particular height we do not want to know it also. Drop from that. What is now the distance traveled in the t seconds? Because what is going to take the time is going to be the same as what is coming down to the same point. Therefore in t seconds. Therefore now you know this particular height, what they are asking is half gt squared, because u is equal to 0, right? No, there was simpler way of solving problem. Therefore there is no need for us to know something about the u value. It doesn't matter whatever is the speed. What they are asking is what distance covered in the last t seconds. Last t seconds upward going is equal to first t seconds downward travel. Therefore that is the way of looking at things. Then you go to the next problem. A stone is released with 0 velocity from the top of a tower, reaches the ground in 4 seconds. What height of the tower? Same formula, half gt squared is going to give you this. Because now from the top it is now u equal to 0, g downwards is going to take. Now what is now height of the tower? H is equal to S equal to ut is going to be 0 plus half gt squared. T is given as 4, 16 into 5. Because as I told you that always remember this half g as 5t squared. That means you can remember this particular formula straight away as this ut plus 5t squared. Okay, plus or minus depending upon how you are going upward means then it is minus 5t squared. If you are downward going only, then it is 5t squared. Therefore this can be easily remembered as like this. Now in this case, because anyway now you are thinking about dropping it from u equal to 0, then this term vanishes. Always remember this as s equal to 5t squared will be a very useful formula for you to remember. Of course now I am saying you just try to remember, but then as you go along practicing a lot of problems, you would automatically remember all these formulas by heart. Therefore 5t squared, t is equal to 4, so 5 into 16, 80 is the answer. Okay, now next. Now go to this. Water drops fall at regular intervals from a tap 5 meters above the ground. This is now the ground, this is now this thing. Therefore, it is falling. Falling means this is with initial velocity equal to 0, that is released from rest, 5 meter. The third drop is leaving the tap at an instant when the first drop touches the ground. Now this now one drop is here. Then this is now the third drop is about to leave. Therefore, there will be some other drop somewhere in the middle. Okay, need not necessarily be only in the middle. It will not be at the middle of the height. Okay, it will not be middle of the height. Can you imagine whether it will be less than middle of the height, whether it will be somewhere here or somewhere here? Obviously, it will be somewhere here because now the velocity during this particular, the average velocity is going to be lesser than velocity here. Therefore, it will cover less distance. We will now see how. Okay. Now, how far above the ground from the second drop is the second? They are now asking what is this particular height h, because this now the second drop is going to be here. What is the height h? Given that this is 5. Okay. Now. How to find this? This is now 5 meter. What about this? Think how you're gonna find. Okay, now let me now give you a clue. This is now the time taken. Okay, let me now redraw it nicely here. Now this is now the topmost point. This is now the bottommost point, and then somewhere here is the middle drop. Now time, water drops fall at regular interval means now the time during which now the second has fallen, this time is now the same as from the second to the third, the time has fallen. Or rather, this is now time of fall is 2t, this is now t. Therefore, now it's a question of they are asking how far above the ground is the second drop at that particular point. That is, they are asking this height h. Now, you know that because this is going to be free fall from here, this is equivalent to half g t squared. Whereas now the whole fall is equivalent to half g into 2t ka whole squared. Therefore, then what is the ratio of the distance between this and this? If now this is 1, then the total is 4. Correct, no? Total is 4. That means 4 is given as 5 meters. Total is 5 meters. Therefore, then what is 1.25 meter? Now they are asking what is this height. This height will be 3.75. Well, understood? Now this is kind of a shortcut which I am now telling you. Now, later on you are going to have something called as well-known result. Okay, we'll come to it. I'll be covering that also because that will be very, very useful. Now, but then straight away I can say that later on I will use a well-known result like this. If u equal to 0, then ratio of distances covered. Mind you, this again is nothing but constant acceleration situation only. This particular result holds good. Not for every other varying situation. Only for constant acceleration situation. Ratio of distances in equal intervals of time, equal t values, is in the ratio of 1:3:5:7 etc. Okay, now it's like this now. Now take for example, now this situation is now free fall under gravity. Now the same thing can be from horizontal straight line motion also. Okay, starting from u equal to 0 is a condition. Now after some time t it is going to be here. After some time 2t it is going to be here. After some time 3t is going to be here. Is going to be here. Now we are talking about now, let's call this as S1 is the distance traveled in the first t seconds. The S2 is the distance covered in the second t seconds, that equal intervals. See, there is now time t, this is also a time t, this is also time t. Therefore now this is S3. Now we are now talking about S1 is to S2 is to S3 is to S4 etc. kind of ratio is I am saying is a well-known result is 1 is to 3 is to 5. That is arithmetic progression with a common difference of 2, starting from 1, etc. etc. Now how I am saying is because this is going to be equal to half g 1 half g t squared. What about this? That is s1 equal to half g t squared. What about s1 plus s2 put together will be now 2t is the time gap, half g 4t squared. Then what about S1 plus S2 plus S3 in our situation? Half G into 3T is the total time, therefore 9T squared. Therefore, then what is S1 is to S2 is to S3, how much? Now, subtract from 4 minus 1. Therefore, this is 1 and this is 4 minus 1. This is 9 minus 4. Next would be 16 minus 9. So on so forth. What is this? 1 is to 3 is to 5 is to 7 is to so on and so forth. That's why I said about now starting from rest, having uniform acceleration. Now the distance is covered in equal successive intervals of time, follows arithmetic progression 1 is to 3 is to 5 is to 7 is to 9, etc. Now you can view this particular problem simply from that angle. Now there is a top point, and then there is a second this thing release is going to be here. The first release already here, third release here, which means now equal intervals of time these have actually no travel. What is now the travel time of the second one is from the top, it is t mean. The first one would have actually traveled 2t. Therefore this is now first t second travel distance. This is now the second t travel distance. Therefore this ratio will be 1 is to 3. Therefore now 1 is to 3. Therefore now total 4 means 5 meters is given. Therefore what is now 3 meters? 3.75 meters. Understood? Therefore, such kind of a way of thinking, using the well-known results in these cases. We will be dealing with the well-known results in quite a detail slightly later, but right now we can even apply on this particular problem. Let's now take this. A man throws balls with the same speed, vertically upwards one after the other at an interval of 2 seconds. What should be the speed of the throw so that more than 2 balls are in the sky at any time? Now in the sky at any time. That is more than 2 balls means now the limit is there are actually 2 balls. That means one ball is here, then the one ball is here. Just 1 second. One ball is here means other ball just now reached here. Okay, then what happened? Then just in the limit, 2 balls are there in the sky at any time. Okay, that is the meaning of this. Now interval is now 2 seconds. Therefore, interval between the first ball is being thrown, second ball just now reaching. Now the interval is 2 seconds means one way upward is 1 second. Okay, now what should be the speed? Therefore, u by g should be equal to 1 second. Because u by g is the time taken for one-way travel. U by g equal to 1 second means they are asking what is the speed of throw u. So u must be equal to 10. That is, now that should be less than 10 here. At least 9.8. Therefore, then what should be the time of travel should be at least 1 second. That means u squared by 2 u squared by g. I mean, or rather u by g rather, because time of travel, u by g must be at least 1 second. That means greater than 1 second. Therefore, u must be at least greater than 10 meters per second. Now here they are asking us to take g equal to 9.8. Therefore, at least 9.8 meters per second is the answer. Understood? Now, let's take the next case. If a ball is thrown vertically upward with a velocity of 40 meters per second, then the velocity of ball after 2 seconds will be. Now, quite simple, because every second is going to be g reduction, 10 meters per second reduction in the velocity. After 2 seconds, 20 has gone. Therefore, balance is 20. Correct now? This is now pretty simple for us to use. Next one. body dropped from the top of a tower fall through 40 meters in the last 2 seconds of its fall. Therefore, then height of the tower is how much? Can you now try this on yourself? How to do? Then I'll come back and then tell you also how to do it, how to do this. Okay, now let me now explain. This is now the bottom ground, this is now the top of the tower. This is u equal to 0, it is dropped. Then it is falling down to the ground. Now the last to 2 seconds, therefore let us say from here, okay, this point may be, let us say P, and therefore this is now going to take time it is equal to 2 seconds. Now they are asking what is the height of the tower, h. Now how to do it is, we will take this as unknown time of fall is t. Therefore now this is going to be 2 seconds is going to drop from here. This is going to be t minus 2 seconds. This much time is t minus 2 seconds. Therefore then what is this height up to this? Half g into t minus 2 seconds, because starting from u equal to 0. Then what is this height going to be? Half g full t squared. Therefore then what is this is going to be? Now the difference between this and this. Okay. Therefore then this is given as how much it is? It is covering a distance of 40 meters. Therefore now it is given that half g t squared minus half g t minus 2 whole squared equal to 40. Okay, now as I said, now half g take it as 5. Therefore that actually means t squared minus t minus 2 whole squared equal to, divided by 5 is equal to 8. Understood, no? Therefore what is this? 2t minus 4 equal to 8. Check it up. T squared is gone. Then this is minus 4t. Or rather 4t is going to be here. Then minus 4. The 4t minus 4 is equal to 8. Therefore t is equal to 3 seconds. Therefore total time of fall is equal to 3 seconds. Therefore half g t squared. Therefore half g into 9 equal to 45 meters is the answer. We got it, no? Fine. Okay, let me just repeat what is the method. Understand? We want to find what is the total height. Now it is given that the last 2 seconds coverage is 40 meters. Let me just now do this. Okay, last 2 seconds is covering 40 meters. Therefore then what is the height of the tower? Okay, we do not know the total time of fall. Let's call it as t. Okay, because then the height can be calculated as half g t squared is the answer if you assume unknown t. Therefore now the total time of fall, let it be t. Therefore now this is going to last 2 seconds here. Therefore time of fall until this height is going to be t minus 2. Therefore now what is now the distance of fall in t minus 2 seconds equal to half g t minus 2 seconds distance of fall. What is the distance of fall for the total time t, half g t squared? Now the difference between them is given as 40 meters. This minus this is 40 meters given. Therefore now g equal to 10 you put and then solve, you get now time equal to 3. Therefore put it back into half g t squared, time equal to 3, you get half g into 9, 5 into 9, 45 meters. Fine. Now this is the way in which a step-by-step approach we have to solve it. Now there is another approach which I want to now teach you, because it will be quite interesting if you can do it. Now we can do it actually. Now this particular another method you can do it totally mentally. Now look at it this way. Now during the last 2 seconds, what is the distance covered? 40 meter. Therefore then what is the average velocity during this particular last 2 seconds? You know average velocity s by t. Therefore 40 meters it covers in 2 seconds. The average velocity is 20 meters. Therefore during the last 2 seconds, average velocity is 20 meters. That means from the top it has taken 2 seconds to reach the average velocity. Okay, no, 2 seconds. Therefore 2 seconds it has now reached. Then also you know that average velocity is like this. Average velocity is the midpoint of the time interval. Now what is the time interval total now? 2 seconds. What is the midpoint is here is Now this is 1 second from here. Now it is given that it reaches 20 meter per second, mean it has now taken 2 seconds to travel this, out of which 1 second is gone. Therefore, now this is now 1 second. That means now 2 plus 1, 3 seconds is the total time of fall. Therefore, half g t squared is 45. Let me now repeat the mental process of quickly doing it without any one of this kind of a figure or actually drawing like this. Look at it like this. Last 2 seconds, 40 meters. The average velocity is 40 by 2 equal to 20 for the last 2 seconds travel, equal to 20 meters is the average velocity. As you know, average velocity in the case of a uniform acceleration motion, this I told you is only for holding it only if it is a straight line graph. Average is nothing but the time interval by 2. Okay, at this particular point, what is velocity is called the average velocity, because this is u, this is v. Therefore, u plus v by 2 occurs at time interval. This now t means from 0 mean at t by 2. The midpoint of the time interval is the average velocity. Therefore, now it is given, now this particular time interval is now 2 seconds, last 2 seconds. Therefore, now this is 1 second, this is 1 second. Average velocity is now 20. That means now it has reached a velocity of 20 at the end of 2 seconds. Why? Because this is 2 plus 1. That means now the total time of travel is 3 seconds. Therefore 5 into 3 squared, half g t squared for the total time of travel, it gives you the total height. H is equal to 45. Understood how it is done by means of a very fast method of, even mentally you can actually do it very fast. Understood? Okay. Now these are the kind of situations where I wanted you to remember. Then the next topic we're going to take up is, we already covered the constant acceleration motion by means of equations. Now the next topic we are going to have to deal with is graphical questions. Okay, graph type kind of questions. We will now deal with them also.